in this problem called bracket sequences 2. So it is a continuation of the previous problem, bracket sequence 1. So I recommend solving that problem before moving on to this one. Our task is to calculate the number of valid bracket sequences of length n when a prefix of the sequence is given. In the previous problem, we were not given any prefix. So we were given only n, the length of our target string, and we were asked to find the number of valid bracket sequences. So this task is harder because we are given a prefix and we need to find the valid bracket sequences that go along with this prefix. So we will be given a number n that represents the length of the target string, as well as a prefix of length k that can be up to n, and we have to output the answer to the problem modulo 1,000,007. So let's head to the drawing board to recall what we did in the previous problem and to see how we can solve this one. So in the previous problem we were given n, the length of our target string, and we were asked to find the number of valid bracket sequences of length n. And we managed to find a closed form formula for this quantity. And we first noticed that if n is odd, then the answer is equal to 0. Otherwise, we can represent n as being equal to 2 times k, and we said that our answer was equal to the binomial coefficient of 2k choose k minus the binomial coefficient of 2k choose k plus 1. And we also said that this was equal to the kth Catalan number. So let us recall how we came up with this formula. We said that the number of opening brackets must be equal to the number of closing brackets, and we found out that the number of strings of length n is equal to 2k, where the number of opening brackets is equal to the number of closing brackets, was equal to 2k choose k. Because basically defining a string of length 2k means that we have 2k positions and we have to choose k such positions where we're gonna put the opening brackets, and the remaining k positions, I have one too many, so the remaining 3 positions will have the closing brackets. But as you can see from this example, this is not a valid bracket sequence. Therefore, the number of strings of length n equals 2k, where the number of opening brackets is equal to the number of closing brackets, are not all valid sequences. And what we noticed last time is that starting from any invalid bracket sequence, we can map it bijectively to some other sequence. For example, this is an invalid bracket sequence, and it becomes invalid right from the start here. We cannot start with a closing bracket. We have to start with an opening bracket. So we just pinpoint this position where it becomes invalid. Then we switch all the remaining characters. If it was open, we're gonna change it to closed and vice versa. So this will remain closed, then this will become closed as well. This will become open, open, and this will become closed. So as you can see in this part, we have 3 opening brackets and 2 closing brackets. And in this part, we only have 1 closing bracket. So after we switch these, we will end up with 3 closing brackets and 2 opening brackets for a total of 4 closing brackets and 2 opening brackets. So if we start with k closing brackets and k opening brackets, we're gonna end up with k plus 1 closing brackets and k minus 1 opening brackets. So all the invalid bracket sequences can be accounted for with this, and this is equivalent to finding the number of bracket sequences of length 2k, where we have k plus 1 opening closing brackets and k minus 1 opening brackets. So that would be equal to 2k, choose k plus 1, and this is exactly what we have here. So this is the total number of bracket sequences where the number of opening brackets is equal to the number of closing brackets, and this represents the number of invalid bracket sequences, so their difference should give us our answer. So now let's see how we can use what we found so far to build up our answer with the additional constraint of a prefix. So in this problem we will be given some n that represents the length of the target string, and we will also be given a string that represents a prefix of the target string. So our prefix can be something like this, and this prefix is, for example, of length 3, and the length of this prefix will be less than or equal than n. So as with the previous problem, a few things to know this. So if n is odd, then no solution. But there are also some other cases where we will not have solutions. For example, if we had this as a prefix. So if this is a prefix, it's already an invalid bracket sequence. So no matter what I put in the n minus k substring that remains, this bracket sequence will remain invalid. So the first thing we have to do is to go through this bracket sequence and make sure that the number of closing brackets never exceeds the number of opening brackets. In this example, we're gonna end up with 2 opening brackets and 1 closing bracket, and the partial sums of opening and closing bracket was always positive. So here we have a plus 1, plus 2, minus 1, so we end up with 1. We never went below 0. So this is a valid prefix. And we ended up with 1 extra opening bracket because the difference between 2 and 1 is 1. So basically this bracket goes with this, and we are left with this bracket that needs to be assigned to some bracket in the remaining substring here of length n minus k. So let's work out this example. Say n is equal to 6 in this case. So we will have to find all strings of length 3, which is equal to 6, minus the length of this prefix, which is 3. So we need to find all strings here such that they form a valid bracket sequence along with the previous prefix. So will this be a valid answer? And it's clearly no, because in the whole string we have 2 opening brackets and 4 closing brackets, so that does not work. And we can tell from here that since this part has 1 opening bracket left, then this part needs to have 2 closing brackets and 1 opening bracket, so they will add up to end up with 2 opening brackets and 2 closing brackets. So basically from the prefix we will know the number of opening brackets left, and we will try to match it with the number of remaining strings here. Let's consider a different example. For example, n is equal to 8, and we have this as a prefix. So we have 5 opening brackets, and so far there is no problem because the number of closing brackets never exceeded the number of opening brackets. But what you see here is that we are left with a substring of length 3, since this is of length 5, and it has to contain all the closing brackets for 5 opening brackets, which means 5 closing brackets, which is impossible. So a second thing we have to account for is that the number of opening brackets here need to be small enough to be matched with the remaining substring. And one easy way to check for that would be to calculate the following. So we know that the remaining substring will have length n minus k, and we may get some opening brackets from the prefix. So n minus k plus the number of opening brackets should give us, if we divide it by 2, it should give us the number of brackets like opening and closing. For example, here we have one opening bracket and n minus k in this case was 3. So 1 plus 3 divided by 2 is equal to 2. So indeed we have 2 opening brackets and 2 closing brackets, and we can make this sequence valid, for example, if we change this to a closing bracket. And if, for example, like in this case, we calculated n minus k, here it will be equal to 3 plus 5 divided by 2 will be equal to 4. So which means that in the whole thing we should have 4 opening brackets, but we already have 5 unmatched opening brackets from the prefix. So that's why we know that this won't be possible. And this is pretty much it. So once we know the number of opening brackets and closing brackets in our remaining substring, we can use the same trick as in the previous problem to calculate all valid bracket sequences. So like in this example, in this substring we will have one opening bracket, or rather we will have one opening bracket and 2 closing brackets, because with the one opening bracket from the prefix we will have 2, and basically all such substring will simply be equal to 3 choose 1, which is also equal to 3 choose 2, but not all of these bracket sequences are valid. So for example, we have this here, and as we said, for example, this would not be valid. It indeed has 2 opening brackets and 2 closing brackets, but it is not valid, and it becomes invalid precisely at this position. But if we go ahead and do what we did in the previous problem, we can switch the remaining here to the opposite bracket kind. So this becomes closing, and this also becomes closing. So we started with 2 closing brackets and 1 opening bracket in the remaining part. So once we switch it, we're gonna end up with 3 closing brackets. So the answer in this scenario will be the number of bracket sequences in this remaining substring. So we have 3 characters, 2 of which will be closing bracket sequences, so it will be 3 choose 2, minus the number of invalid bracket sequences. And we said, like in this example, once it becomes invalid, like in this case, if we switch the remaining bracket to the different kind, we're gonna have 1 additional closing bracket. So here we started with 2, then the invalid one will be equivalent to having 3 characters where all 3 of them are closing bracket sequences. So 3 choose 2 gives us 3, and 3 choose 3 gives us 1, so 3 minus 1 gives us 2. And indeed, this is the answer we got in the example. So to sum up, we will just calculate the number of opening and closing bracket sequences in the prefix. We will make sure that the prefix is valid and that the number of opening bracket sequences can be matched with the remaining substring. Once that's done, we will know how many opening and closing bracket sequences will go into the remaining substring, and the answer will be just the length of the remaining substring, which will be n minus k. Choose the number of closing bracket sequences, say C, minus the same length n minus k, choose C plus 1, because once we switch the brackets in the remaining part of the bracket sequence, when it becomes invalid, we will gain an extra closing bracket. So that's pretty much it. Let's go ahead and check out our code. So this is our program. I will use the struct we introduced in previous problems again. So this allows me to calculate the factorials up to some numbers. So this is the constructor of this struct. I give it n, the maximum value of factorials I want to calculate, as well as the modulo I want to use. So I resize my array to be size n plus 1, and I set modulo to be equal to modulo. Then I calculate the factorials recursively. Then I have a couple of getter functions. So this is to get the factorial of some number. I'll just return the value in the array. And this is a function to get the inverse factorial. As we saw in previous problems, we cannot manage division when we are calculating modulo some number. More precisely, if we have a divided by c mod p, this is not equal to a mod p divided by c mod p. But what we can do instead is multiply the numerator and the denominator by what is called the modular inverse of c. And basically the modular inverse of some number is just the number that when multiplied by that number gives us 1 mod the prime number. So if we multiply both numerator and denominator by the inverse of c, the denominator will simply be equal to 1. For example, the modular inverse of 2 mod 5 is equal to 3, because 2 times 3 is equal to 6, which is congruent to 1 mod 5. So for example, 6 divided by 2 would give us 3, which is congruent to 3 mod 5. But if we were to calculate this as being equal to 6 mod 5 divided by 2 mod 5, we will get 1 divided by 2, which is wrong. Whereas if we multiply the numerator and the denominator by the inverse of 2, which is 3, as we said, we will get 6 times 3 divided by 2 times 3, and this is equal to 18 over 6, or rather over 1. And 18 mod 5 is indeed equal to 3, so we can see that this matches. So back to our problem. And I have this function because we're gonna need it to calculate the binomial coefficients. So the binomial coefficient, as you know, so a choose b is equal to a factorial divided by b factorial times a minus b factorial. So we're gonna need to bring this to the numerator, and to do that we'll just multiply by the modular inverse of b factorial and a minus b factorial. So that's precisely what we did here. So the factorial of a times the inverse factorial of a minus b times the inverse factorial of b. And just using modulo here to make sure that things do not overflow. And I have this extra condition here, which the binomial coefficients satisfy to stay consistent even in special cases of a and b. So by definition, 2 choose 3 will be just equal to 0. Basically, we cannot choose 3 elements from 2 elements. And also the binomial coefficients of any negative number will be just 0. So that's pretty much it. Here I defined my modulo to be equal to 1,000,007,000. And then in my program, I'll start by reading n the length of the target string. Then I will initialize my factorial struct, and I will calculate factorials up to n plus 10. This is just some buffer. N would have been enough. Then I will read my prefix. I will check that n modulo 2 is even, and if it is odd, I will just print 0 and return. Then I will count the number of opening brackets and closing brackets in the prefix. So I'll look through my string, and every time I encounter an opening brackets, I will increment my opening bracket count, and I will do the same for closing brackets. And if I ever find that the number of closing brackets is strictly greater than the number of opening brackets, I'll just return 0 because I will have a prefix that is invalid, which will render the whole string invalid. Then I will check that the number of opening brackets I calculated so far can be matched with closing brackets within the length n. And to check for that, I will just make sure that the number of opening brackets times 2 is less than or equal to n. And if it is greater than n, I'll just return 0 as well. And finally, I'll just calculate the length of the remaining substring. As we said, it's gonna have length n minus k being the length of the prefix, so I'll just minus that from n, and I will calculate the number of remaining closed brackets, which will be equal to the number of left open brackets, which is opening brackets minus closed brackets. So however many opening brackets I have left to close, plus the remaining length of the string. Remember here, n does not represent the whole string anymore after I perform this subtraction. Here it only represents the remaining substring. So whatever remains of the remaining substring plus whatever how many opening brackets I have left divided by 2 will give me the number of remaining closed brackets. And the number of remaining opening brackets will be just n minus the remaining closed brackets, because the number of remaining open brackets plus the remaining closed bracket should fit within that substring. And finally, once I have these two quantities, I can just calculate the answer as I did with the previous problem. So I'll just output the binomial coefficient of n, choose the remaining closed brackets, minus the binomial coefficients of n, choose the remaining closed brackets plus 1. And notice here that I add an extra modulo here, and I have to do that whenever I perform a subtraction modulo some number, because let's consider the following example. Suppose the answer that the checker will test for is 1, and I perform this following subtraction. So suppose the first part of what we had there was equal to 0, and this was equal to a billion plus 6. So the difference here will be negative a billion plus 6, which is still congruent to 1 mod a billion plus 7. However, I will print the wrong answer, and once checked against 1, it will return false. So basically, this has to be always added to the modulo. So if we add the modulo to it, we will get negative a billion plus 6 plus a billion plus 7, which will give us just 1. So to make sure we print the exact answer as the checker, we need to make sure that this belongs to the interval 0 mod minus 1. And to do that, we'll just add modulo. So that's pretty much it. Let's go ahead and submit. So that worked. Thank you very much for watching. See you in the next video. Bye bye.